What if I told you that the most revolutionary technology of our time was inspired by the human brain? Neural networks are the powerhouse behind everything from your smartphone's face recognition to self-driving cars. Today, we're going to break down exactly how these incredible systems work, starting from the basics and building up to real-world applications. A neural network is essentially a machine learning model that mimics how our brain processes information. Just like our brain has billions of interconnected neurons, artificial neural networks have interconnected nodes that process data and learn patterns. Think of it this way. When you see a cat, your brain doesn't have a pre-programmed cat detection rule. Instead, millions of neurons work together, each contributing a small piece of the puzzle until you recognize that's a cat. Neural networks work similarly. They learn patterns directly from data without being explicitly programmed with rules. Every neural network has 5 essential components. First, neurons. These are the basic processing units. Each neuron receives inputs and decides whether to fire based on a threshold and activation function. Second, connections. These are the pathways between neurons that carry information. Third, weights and biases. Think of weights as volume controls. They determine how much influence each connection has. Biases help neurons make decisions even when inputs are weak. Fourth, propagation functions. These mechanisms process and transfer data across different layers. Finally, learning rules. These are the algorithms that adjust weights and biases over time, making the network smarter with experience. Neural networks are organized in layers, like a multi-story building. The input layer is your ground floor. This is where data enters the network. Each neuron here represents a feature in your data. Hidden layers are where the magic happens. These middle floors do the heavy computational work, transforming inputs into something useful. You can have one or multiple hidden layers. The output layer is your penthouse. This produces the final result, whether that's a classification, prediction, or decision. Data flows from bottom to top, getting processed and refined at each level. Neural networks learn through a 2-step dance called forward propagation and back propagation. Forward propagation is like throwing a ball through the network. 1. Data enters the input layer. 2. Each neuron performs a linear transformation, multiplying inputs by weights and adding bias. 3. The result passes through an activation function that adds nonlinearity. 4. This continues layer by layer until we get an output. Backpropagation is the learning phase. 1. We compare the network's output to the correct answer using a loss function. 2. We calculate gradients, basically asking how wrong was each weight. 3. We update weights in the opposite direction of the error. 4. We repeat this process thousands of times. It's like learning to throw a basketball. You miss, analyze what went wrong, adjust your technique, and try again until you consistently hit your target.
Let's see this in action with email spam detection. Imagine we have an email that says, "Get free gift cards now." Step 1. We create a feature vector based on keywords. Free, present, 1. Win, absent, 0. Offer, present, 1. Step 2. Our hidden layer processes this. Let's say we have 2 neurons with different weights. Neuron H1 calculates 1 times 0.5 plus 0 times negative 0.2 plus 1 times 0.3 equals 0.8. Neuron H2 calculates 1 times 0.4 plus 0 times 0.1 plus 1 times negative 0.5 equals negative 0.1. Step 3. We apply ReLU activation. H1 output, 0.8, stays positive. H2 output, 0, negative becomes 0. Step 4. The output layer processes these values and gives us 0.636. a 63.6% probability this email is spam. Since it's above our 50% threshold, we classify it as spam. Just like there are different tools for different jobs, there are different types of neural networks. Feed-forward networks are the simplest. Data flows in one direction from input to output. Convolutional neural networks, or CNNs, are image processing specialists. They use filters to detect features like edges and shapes, making them perfect for facial recognition and medical imaging. Recurrent neural networks, or RNNs, have memory. They can remember previous inputs, making them ideal for language processing and time series prediction. Long short-term memory networks, or LSTMs, are special RNNs that can remember information for very long periods, solving the problem of forgetting important details. Neural networks are everywhere in our daily lives. In healthcare, they're diagnosing diseases from medical scans, sometimes more accurately than human doctors. In finance, they're detecting fraud, predicting stock prices, and assessing loan risks. In transportation, they're powering self-driving cars, optimizing traffic flow, and enhancing GPS navigation. In entertainment, they're recommending your next Netflix show, generating realistic game graphics, and even creating music and art. The applications are limitless and growing every day. Neural networks are powerful, but they're not magic. Advantages include incredible pattern recognition abilities, adaptability to new situations, parallel processing capabilities, handling complex nonlinear relationships. But there are challenges. They need massive amounts of data. Training requires significant computational power. They're black boxes. It's hard to understand their decision-making process. They can overfit, memorizing training data instead of learning general patterns. We're just scratching the surface of what neural networks can do. As we develop more efficient architectures, better training methods, and more powerful hardware, we're moving toward artificial general intelligence. The key takeaway is neural networks aren't just computer science. They're the foundation of the AI revolution that's reshaping every industry. Whether you're a student, professional, or just curious about technology, understanding neural networks gives you insight into the future we're building. Thanks for joining me on this journey through the fascinating world of neural networks. If you found this helpful, subscribe for more AI content and let me know in the comments what aspect of neural networks you'd like to explore next.